Welcome to Study Loop.
So in this question we have f of x and y is our PDF, which has value cxy squared when x is less than y is less than 1, and they're both bigger than 0, and 0 otherwise. So first of all, let's find the value of c. So the integral from y is 0 to 1, and the integral of x from 0 to y, cxy squared dx dy, has got to be equal to 1, because that's the integral over the total area of the probability. So let's do the x integral first. We get c over 2 x squared y squared evaluated between x equals 0 and x equals y. And then we integrate that dy. That's got to be equal to 1. So now let's integrate this. So let's evaluate this. When x is y, we just get y squared. When x is 0, we get nothing. So we get c over 2 y to the 4 between 0 and 1, which has to be equal to 1. So that gives us c over 10 y to the 5 evaluated between 0 and 1 equals 1. But this is just c over 10 equals 1. So c is equal to 10. Part 2, we need the probability that x plus y is equal to 1. And this is obviously going to be 0 because we can see what this is. So this is the integral dx from 0 to y, and the integral dy from 0 to 1 of the probability that x plus y is equal to 1. So that means that x has got to be 1 minus y. So we get c 1 minus y. But then we can't actually integrate from 0 to y with respect to x. It can only be, it's the integral from 1 minus y to 1 minus y dx, cxy squared, because there's only this one line on which this event is holding. But this integral is obviously 0, because we're integrating between two limits which are the same point. So this is just 0. Okay, now part 3, we need the probability that y is greater than a half. So this is going to be the integral from 0 to from 1/2 to 1 with respect to y, and the integral again from 0 to y with respect to x of the integrand, which is 10xy squared. So from 1/2 to 1 with respect to y, then the x integral gives us 5y to the 4. So now we can integrate that, and we just get y to the 5 evaluated between 1/2 and 1, which is 1 minus 1 over 2 to the 5. So 1 minus 1 over 2 to the 5 is 31 over 32. So the probability that y is greater than a half is 31 over 32, or approximately 0.97. And now part 4, what's the probability that x is less than a half? Well, now we can exchange the order of integration. Instead of integrating x first, we can integrate y first. Then x can go between 0 and a half, and y has to be bigger than x. So y can go from x to 1. And then our integrand is again 10xy squared, and we're integrating y first, then x. So integrating y first, we get 10 thirds xy cubed evaluated between x and 1. So that's the integral from 0 to a half of 10 thirds x minus 10 thirds x to the power of 4. So that's going to be 5 thirds x squared minus 10 twelfths x to the power of, minus 10 fifteenths, so that's 2/3 of x to the power of 5, which we evaluate between 0 and a half. So that gives us 5 over 3 times 1 over 4 minus 2 over 3 times 1 over 2 to the 5, which is 19 over 48. So that's our probability that x is less than a half, or approximately 0.396.